thank you all for coming. So we have with us Jared Millman. He's also a writer speaker, keynote speaker tomorrow. You've seen him already at the tutorials. Jared is a little hard to describe in the sense that he's had so many roles to play in the past. He has coordinated SciPy for multiple years. He was a core contributor to SciPy, involved in several of the SciPy releases earlier on. He was also director of computing at the Neuroscience Institute in Berkeley. And now he's switched gears and gone back to becoming a student of biostatistics at Berkeley currently. He also teaches a course currently, computational science for reproducible and collaborative science, statistic science. And grateful that he's with us here. We have Professor Supratik Chakrabarti, who is in the Computer Science Department of IIT Bombay. His research work is on validation and verification, formal validation and verification. And he has been intimately involved with the KV IIT school here. As soon as I saw that, I latched on to him and requested him to come. He was kind of reticent, but I requested him to come, given that he has experience directly interacting with the teachers. We have Dr. Ajit, who has for many years spearheaded pretty much single-handedly the adoption of Python for science experiments, and has made his own open hardware, various devices he has made that have been used in many colleges, inexpensive open hardware, completely free. Sorry, ran out of battery. So Professor Kannan Moudgalya needs no introduction. He has been a speaker at SciPy India for multiple years, but regardless, I should introduce him. He is kind of the driving force behind a large number of NME ICT related projects in IIT Bombay and elsewhere. Nobody knows to this day how he gets the energy he does. He has phenomenal energy to be involved in such a wide variety of projects. And he has such an enormous enthusiasm to do good for the entire country's education, starting with his involvement with long distance education through CDEEP, and then continuing on with variety of projects that are almost entirely not related directly to his research. I don't know how he finds the time to do both his research, publish books, and also spearhead multiple projects that actually involve, FOSSEE itself, he was the driving force. He continues to be a huge influence. Multiple other projects as well, which are purely directed towards improving the quality of education in India. He is also a chemical engineering professor at IIT Bombay. And then we have from KV IIT a physics teacher who has very kindly joined us at rather short notice. He teaches in the KV IIT at campus, and he has also been reticent to join us on the stage, but we believe that he is an extremely important member on this panel, because we're going to try to make whatever material we want to do is to help the teachers. Thank you very much to you all for being here. He has also brought with him several other colleagues, and we also have other teachers in the audience. We solicit all of their feedback. So with this introduction, first we thank you again for being here and sparing your time. So my first question to the panel, I have a set of prepared questions that I have calculated. We'll try to get through these somewhat quickly. The first question I have is, I'd like you to share a little bit briefly about your experiences introducing computers and programming in the curriculum in the context of science and engineering. Not in terms of computer science, unfortunately, or even if it is a computer science, your experiences introducing computation and programming in these courses, and how it has affected both you and the student. So, your comments, please.
Yeah, so I guess I've mostly dealt with science and engineering students, not computer science students, and I've dealt with them mostly at the university level. One thing that I guess exciting about this project to me is that many of the students I've met haven't had a lot of background in computer science. They almost all of them have not had any programming classes, which was surprising to me because when I went through junior high and high school, I didn't have those. It was a great opportunity, and I think most of the people that I interact with that have done a lot of programming have started early. So I think it is important to start people at a very young age. I've also heard a lot of experiences with people that have tried this kind of idea of trying to teach computational ideas with computational tools. Not computing, but sort of ideas about computing or computations. And talking about students who, when you give the lecture or talk about the theory behind these things, sort of zone out. But when they actually can change parameters and maybe find some unstable point in an equation or something like that, they sort of really get something and they have this aha moment. So I think it sounds like a great idea. I also think probably most people have not had computing background because a lot of the computational training is geared much more toward computer science. So I think putting this into the physics or mathematics or engineering curriculum is probably the right way to go.
So I teach in the computer science department, so I won't talk about how to use programming for computer science for computer science students because that's what they're supposed to learn. I'll talk briefly about my experience interacting with students from other disciplines and also school students, not necessarily in the formal setting of a school, but in the neighborhood and relatives and all of those. So one of the things that I find is it depends a lot on how you present it. I mean, you can put off somebody from programming for the rest of his or her life in 10 minutes. Okay? So if you just present it that it's such a complicated thing and you have to remember 20 different rules or 20,000 rules, and at the end of it you get something on your screen, that can really put off people. On the other hand, if you try to present programming as a way to visualize, as a way to achieve something that you would have anyway done otherwise, that can create a long-lasting interest and curiosity, which fuels further interest in this. So my experience has been that. So I was looking at the very nice Python scripts that it has written, and maybe the only thing we should ask teachers to do to begin with is to just use those scripts and change the parameters and just see what the fun things that can be done with it. Because once the sort of alienation happens to begin with and once it looks like something that's hard for somebody to grasp to begin with, it becomes very difficult to, the motivation to come back to it later is far less. So, just to narrate my own experience, I have been able to get my aunts and uncles who are like 60 years plus do simple Python programming because I could just show them that they can do something that they would like to do rather than, of course, it's not a while loop iterating, it's just a straight line program, but something is being printed out and something is being read from the input. So I think a lot depends on the way you presented it. It can be very effective, but if it's presented wrongly, it can just put off some person.
Thank you. It's very, very nicely put. It should be put.
Yeah, as far as I am concerned, my experience is mostly trying to teach people how to do science experiments, accessing hardware and all. So this project started some 10 years back. So the C language was used. And that time the only option was you show the code, but finally they use only the executable. But fortunately, someone else forced me to move to Python. And what he did was, he took my C code and wrote something in Python, translated and published it in some online journal. And that convinced me, okay, it's better to switch over. So that was 10 years back. And after that switching over to Python, the improvement was dramatic. Now, every year we conduct the 6 days training program for physics teachers from all over India. It's only a small number, we take only 20 teachers. But within this 5-6 days, those who have never done any programming also, I mean, at least they are capable of doing whatever I explained here and also reading data from a hardware device and plot it and all. So that way, I mean, using Python had been actually a positive experience. But still what is really bothering, I mean, the reason for even thinking about this is somehow we are unable to get the school teachers and students. And that is where the issue is, I mean, with what kind of program we should approach them. And that's probably the more input should come from the audience, I think.
So, if you are, excuse me, if you are amongst the last speakers, then everything is already said. There is not much to say. So, all good points have already been explained by the previous speakers. I would just want to point out the methodology that we used for self-learning. We implemented in Spoken Tutorial. It is basically what was said earlier. Don't go into too much theory, because normally when we teach a class live, and of course in any elite institution, we will first teach the theory and say, generalize it and say, here is an example, another example, and so on, and how great the theory is, and so on. So that doesn't work for beginners. And in our methodology, in the Spoken Tutorial methodology, we wanted people to learn by themselves. So we actually turned it around and said that we should help them learn by examples. So you have example 1, example 2, example 3. So there is not much of many questions that the students have when they go through this. Otherwise you start teaching theory. There is visualize a student at a remote location, alone, trying to learn, and he or she has a question, don't know whom to ask. But on the other hand, if you say that, okay, do this example, do you get this answer? And it's very easy for him to, do that and get that example. And one after another, and then finally you say, this is the theory behind it. So as a matter of fact, we enforced a rule that in our Spoken Tutorials, 80% should be something that they should reproduce. In fact, we quantified that. And 20% only should be for theory. So I agree with this observation that we should let people try out various things and then learn by that. And finally, I think one of the reasons to answer the question that Ajit raised, how do we make inroads? I think the biggest obstacle to this, I would say, I don't know, maybe I'm biased by what I saw several years ago, that the open source community is very rude, very unhelpful. Maybe it has changed somewhat now, but I have seen beginners getting driven out, saying that, don't you know even this? So I think if we really want to do this, we have to, if you want to go to schools, we have to say that we are here to help you. Ask any question. There is no question, stupid question. Okay? I think that is my contention. Thank you.
First of all, I thankful to organizer for giving an opportunity to me to attend this program. So this program is very helpful to us as a physics and maths teacher. So yesterday I learned pendulum, LT square graph. Immediately I imply in my school. Actually today I taught that topic, LT square graph, in practical exam. So immediately I used how the graph is there, LT graph, LT square graph. So this is a very useful Python and already that is in a CBSE syllabus. So, but here is an option, C++ programming and Python. Our KVS used only C++ program. So, this program to learn Python language and to use Python language, this is a very essential for physics and maths teacher in a school. So, I also request organizer, you organize as like a workshop for the physics teacher and maths teacher. So what happened, while we are teaching this, any theory, I am actually experimental person. So every points while I am teaching, first I doing experiment, then I explain beyond that theory. So today I seen here, sir, you in your session. So that is damping oscillations or all that. When I am teaching this oscillation point, there only I explain by theory. Oscillation is as like, and this damping is as like law graph. When I am getting this program, and in front of my students, I am showing this program with this actually damping process, then student can understand easily. So this is very essential. Okay, thank you.
Thank you. So I think you can keep it. So just to prevent the imbalance of him always getting the first option. So thank you very much for your answers. So the next question is, so in practice, so most of you have done this at the college level, except I think Professor Supratik and Mr. Ravindra Jain. I think everybody else has mostly taught this at the level of the colleges. So my next question is, how do you think this will be adopted by school students? I mean, do you see any issues with students picking up these topics?
Actually, this is very simple. Python program is very simple. So student can adapt easily. There is no problem. I think even 8th, 9th standard student also adapt this.
So do you, again, so to elaborate, it's not just the language. I mean, do students, are they open enough to, experiment in schools nowadays? Because there are several distractions. They have a lot of homework. They have many things to do. Given all of this, if we introduce something new like this, are they likely to take it up or not? Just asking the panel what their experience, what do they think?
Yes, there is no problem. They are taking. Yes, because this is a very simple language, a simple programming. So if I am doing one, suppose I am taking x into 2 or x into 3, what students are doing, students taking another variable. They try to another variable. So I think students are brilliant than us.
Yeah, I think if we agree that the next generation is smarter than us, we accept it, then everything will be solved. All that we have to do is to ask them to come and explain something, and they will do it. And historically, that is something that for whatever reasons, teachers were a little uncomfortable in accepting that. I think the other issue is lack of computer systems. I think that is one of the biggest problems we have in India. Because regarding the previous one, I can go on talking, but it's not going to get anywhere. Why C++, why CBSE didn't shift to, Python, when Python is a lot more elegant, lot easier to learn without getting bogged down by syntax and so on. One can go on talking about it, but maybe we can take it up later. But I think computer access is a major problem. So I think we need to come up with methods to handle that. We have come up with a solution. In fact, this is a low-cost computer. It costs about 7,500 rupees. It is possible to make this device available. We did some calculation, and per night rental. Supposing a school buys 50 of them and gives it overnight for 20 rupees. People can borrow it, take it home, try it out. For example, as Dr. Ajit Kumar was demonstrating, I could actually do all of that on that laptop very easily. Because you don't need a supercomputer to become enthusiastic about computing, about computer programming. Any program, any device that allows you to do it will work. So it is possible we need to come up with a method. For example, a student says, I want to borrow this today for 20 rupees. I pay 20 rupees, take the machine, and then use it overnight, and then let my brothers and sisters use it, access some email and stuff like that, bring it back in the next morning. I think we have to start thinking about some of those, and we have to, because unless computers are made available, in fact, I always tell that our school buses, our college buses leave at 5 o'clock, and the students go home and they have nothing, and they have no computers, and the exam comes, CS 101 exam comes, or whatever is at the school, and they have to pass, they have to score, they mug up, and they think programming is mugging up. So anyway, sorry for...
No, that's an extremely, very, very vital point. In fact, it's my failure not to ask the question.
Okay.
You obviously need a computer to do it. So part of the adoption in terms of students is to have computers.
Actually, I see in villages also, there are also computer facility
Oh, okay.
in villages, in the school only.
Okay.
But
is it enough? I mean, is it
Student
enough?
don't have. Student don't have.
Student don't have.
Right.
So that's again, so that may be a problem for them to
Yes,
adopt.
I'm doing practicals in every school. I made more than 50 teaching aids, so which are very useful for school teaching class 7 to class 12. So actually, I'm PhD student from Mumbai University. My subject is nanomaterial, but I am doing this for schools children's. So I seen each and every school, high school, normally high school, not ZP school. Normally high school, they having a projector and computer lab, also well equipped computer lab, because Maharashtra government for that is compulsory for all the students. So there is a problem, as sir told, while students doing homework, there is a problem for computers.
Yeah. We have 30 computers for 2,000 students. Okay? And we want everybody to learn Python programming.
I think we are moving into a very relevant question, like how do we bring down the cost? In fact, this is something maybe tomorrow also I'll be talking a bit about it. See, the computing that the cost, hardware cost is coming down. For example, this Vidyut, I mean this tablet. And there are now other laptop, yeah. No more tablet, right? The earlier version was tablet. So another option is like, say, this is, if you take home, this is a very convenient thing. But inside the classroom, suppose there are situations, I want to clarify that. Sometimes 2-3 people share one machine, right? Then if you have a big monitor or something, and a keyboard is somewhat more convenient. And there now we have a lot of options available, like some of the ARM boards, like Raspberry Pi and all coming now. It's a couple of thousand rupees, things are available, and a monitor. And they help in a different front also. You think about the power we are consuming. These boards take 5-6 watts, and you can have a monitor something like 12, 10, 15 watts. And the whole thing, if you have a charged battery, you can run from a solar power. So a school lab, now if you plan, not single machine, if you plan a lab of 10 or 20 machines in this mode, the cost will be less, running cost, maintenance cost also, and energy consumption, everything will be. So we have to probably look into all those aspects. Schools may not do that. Maybe one of these institutions have to have some sample lab, everything worked out, and ask them to emulate probably. I mean, this aspect, to sort it out.
Yeah, so I think accessibility to computers is certainly a problem. Also, I think to begin with, as a first step, I think the teachers should start using it. and then we can move to the students using it, because I mean the kind of things that Ajit just showed, I mean if I change the damping factor, I can see what happens right in front of me, or you know, if I whatever the three-phase thing and so on. So, and the way the charged particle moves in the field. So if I can see all of these in they say pictures are worth more than 1,000 words, and I think this can actually be used for that. So I would say as the first step, because I mean going into schools is probably uncharted territory for us. And as the first step, I think we should emphasize on teachers using these as teaching aids. I mean, in Kendriya Vidyalaya, we now have provided a laptop to each teacher, so the computing resource is there. You know, we can provide workshops, we can arrange workshops and all. And so I think if the teachers start using it, then the benefits will gradually show in their teaching methodologies. And then, of course, we have to move to how students get access to computing resources and how they want to more part in programming. So my emphasis would be first for teachers to get
Correct. So, in fact, our plan is also to first target the teachers, and then through them, of course, students will pick up. One part, there were two parts of the question. One was, how well will a student actually take up the material? It seems clear, you know, we're all in agreement that yes, they will take it up. The second thing, of course, is they will want to experiment. Do they have the opportunity to do that? So, but clearly, the teachers are the first target. That's all.
I mean, if you show such a demo in the classroom, I mean, the interested student might say, you know, I also want to do this, and I also want to play around with the parameters. So that might also create, you know, more interest among students. So I think let's start with teachers using these as teaching tools, and then.
Yeah, so I guess I just have two personal comments, following up on a lot of the same ideas people have talked about. So one was accessibility, and that was something that was a big difference in my upbringing. So when we got our first computer, it really made a difference in my interest in computing, and I spent a lot of time working on it after that. So I can definitely attest to the impact that makes. The other thing is, you know, sort of the application areas of things that would get you excited. And two of the things that one area that I got very interested in early on were computer-generated fractals, which are very easy to do, and they introduce a lot of interesting concepts. So Julia set or the Mandelbrot set, you get into complex numbers. And then with very few lines of programming, you're able to generate something quite compelling visually, and also very interesting. And also the Chaos game, which was used to make the Sierpinski gasket, was something else I learned really early on and thought was you know, profoundly changed the way I thought about the world and randomness as well.
Also, one of my big things for me, I read a book on chaos and then started doing fractals, and I was like, wow, okay, this is really cool.
Yep.
So the next question is, obviously, is the teachers. So teachers in India, teachers in school level have a lot of work. You know, as faculty members now in the college, I kind of really appreciate the amount of effort my teachers must have had to, you know, and school kids being school kids, you don't understand anything at that level unless you actually teach a class. So it's a lot of work for them. So the next question is basically, what do you think about the teachers? Because it's not an easy thing. It's not like their research area. For example, if you pick an average school teacher, they're not doing research in the field. There's very little incentive for a teacher, you know, to go and say, I am going to learn some new technology, a new programming language. They may already be having some inhibitions with respect to this. They may also have issues with respect to, you know, students being very smart with computers. I know people who are scared to send SMS, or, you know, who are scared to work with their cell phones, you know, beyond the point, especially when they're a little older. And so the next question is, as far as teachers go, what can we do, you know, to make it easier for teachers? Yes, we can provide all the material. But do you think that the teachers in India, at the level we are talking about, say 8th standard to 12th standard, will be at least a significant fraction? Obviously not everybody. You know, willing to spend the extra effort it takes and in order to do this. That's like the next question that I have. Because we may produce all the material, we may try to do training, but there has to be uptake on the other, on their side. And given the constraints, given their workload, it's already clear that teachers very often end up teaching because they're passionate about it. They want to make a difference. But
Yeah, so I don't know that I'm the best person to address this, but I can say, one of the things that helps me a lot with teaching is my computing ability. So perhaps there's some advantages thinking of, or some opportunity for thinking about how the computer can make their lives easier or take some of the administrative burden away from them. So I end up doing a lot of things like publishing websites for my courses, or helping distribute materials or prepare materials, grading and keeping track of things. So perhaps that's a way of pursuing it. I guess the other issue is that I guess it'd have to be something that they enjoy doing as well. I find that I can always find a little bit more time for something I'm interested in and excited to do, where things that are tedious for me, even if they don't take much time, seem to swamp everything else, crowds that out.
So, I think this is, we are at the real core of the problem. So I think teachers have a lot to do at school. Class sizes are large, the syllabuses have to be completed. There are all kinds of other activities in the school. So we have somehow got to make this whole thing not as one extra thing to do for the teacher, but as taking off 5 extra things from what the teacher had to do. So the use of computer and the use of such teaching methodologies has to necessarily simplify life for the teacher. Otherwise, I think it's not going to fly. And I think it is possible to do that. There are initial hurdles, barriers will be there. But I think we have to keep this at the back of our mind that if we are saying that teachers have to spend an additional hour every day to do this, I think we might as well forget it.
But hopefully not an hour every day, but even if it is some amount of additional learning on their part, even if it's a...
No, so there will be some initial learning curve, but I think it has to clearly translate to something where it is reducing the load on the teacher rather than increasing the load on the teacher. And, once again, doing things online might actually help, present a class in a more structured way. Being able to use the same Python code to show a demonstration of an experiment by just hitting the enter button is much less time than setting up the experiment in the class every time and showing it, and then, whatever, sometimes it fails for some reasons. So I think it has to be converted to that level where it's helping the teachers. So, your question was, will the teachers agree to this extra load? I think we have to use this to reduce the load. Otherwise, they're already overloaded. So we have to use this to reduce the load, and I think it is possible. What it probably means is that for the supporting ecosystem, we have to take things to a form where teachers can use it ready-made. Teachers can just use it as is, with the minimal amount of investment of their time, and the returns that they get are much bigger. So we have to start off by saying it's a low investment of time and a much larger return. The modulo the initial learning curves.
In this issue, actually, my view is it should never be given as an extra work or any like a compulsion or anything. Teachers should be encouraged to learn, but there is no compulsion, and they should feel it as it's fun. Otherwise, so at the moment they feel it is an additional work, and it's not going to work out. And another comment in this local context which I have is, our teachers, one hurdle in learning computer is, our general belief, this is only typical to India, teachers are expected to know all the answers to students' questions. So here you just forget about it. Teachers should say, okay, you don't know, okay, we don't know, we'll figure out. This field is like that only. no one is supposed to know the answer. Like many times when I give this class, somebody asks, if I change this, what will happen? I just don't ask me. Editor is there, just change it and run it, because the last word is from the system. So that, if that approach is, otherwise what happens is it puts enormous amount of pressure, because your student is asking something, then I have to say I don't know, but here it doesn't matter. You always say, you also did not know, I also did not know, just ask the system. That also probably one.
So I think we have to
factor
encourage,
we
we have
should
to
keep
sort
it
of
in mind.
inculcate that thinking, because normally, as you said, very good point.
That's
Many
our
teachers
concern,
find
right?
it hard to say, look, I don't know. I know in the college level we have to do that routinely because we truly don't know the answer. But I guess we have to maybe tell them that in programming, nobody is an expert. Do expert.
It's an important question. We have some experience in addressing this at the colleges. There is a likelihood that it will get accepted in school. Of course, schools are more bureaucratic because you need several levels of permissions before you can enter a school. Colleges in that sense are a lot easier. When we offered our spoken tutorial based training to colleges, although they were successful, even colleges had difficulty because they couldn't find time after college hours. Because college buses will go away and students would find it difficult to stay back after college hours. It was a problem for the faculty members also, finding resources. So from this July, we started doing what is known as curriculum mapping. In fact, we do this in a big way now. We have, since June this year, we have 1,800 programs in so many academic disciplines, started using some of our training material as a part of the lab. So they anyway have lab, they anyway have lab hour, they anyway have to teach something. So can we do some mapping? So here is the subject, physics has to be taught, this topic has to be covered. Here is the example, using the same example, using the same time, it has to be covered. I think we need to do that mapping for whatever the target software is. So if we say we want to get Python in, so let's get all of it. It is possible that Python may not be the only one. For some other topic, supposing there is an accounting course, you may need an accounting software. So once again, so I think we should create those ethos that we start doing this. It could be hardware, for example. Dr. Ajit Kumar will talk about it if he has not already presented. Maybe in tomorrow, XPICE Junior, how we can use that to conduct physics experiments. So we need to bring in that ecosystem for all subjects. So I would say subject mapping is one area by which we can address quite a bit. That is number one. The second thing that we need to do is, I don't know about school teachers. I have definitely seen in college teachers. I'm pretty sure it is applicable to school teachers also. After some time, kind of boredom sets in the faculty members. So if we can bring in some excitement, if whether it is chaos or whatever games and so on. In fact, one of our MHRD's additional secretaries, one of the top bureaucrats in MHRD in India, she used to say, we need to bring in excitement to our children. Let us bring in games. Let us teach concepts by games. Let's build games and so on. So I think if we can do that, that is also another positive way for us to excite both students and teachers.
I agree with this. Teacher already having a more workload, but this teaching field is very different from other job. How some people's dealing with computer and files in the offices, but we teacher dealing with the minds of the students. So what happened, that is very difficult for a teacher to learn new thing, but some enthusiastic teachers are doing this. And what happened, if we are teaching by traditional method, students not accepting that, because students want something new. Nowadays students are very brilliant, so they want something new. That's why if it is making enjoyable, so there is no problem. Teachers, I think in yearly plan, every teacher making a year plan, then there is one column is there for the teachers, how you use teaching aids, how many times you use teaching aids in the teaching learning process. So we have to show there that I use this so many times, this time, that time, as like. So if I use this, if I am making the class teaching learning process interesting, then students also enjoy. Otherwise what happen, if I using traditional method, students bore and students refuse the teachers. This teacher is not good, this teacher is teaching traditional method. So even my colleague at the age of 50-55, he also used computer teaching aids. He also used PPT. He don't know how to use the PPT till he learn, and he used PPT, and every year inspection is there. Our officer are coming in the school. We making our teaching learning process more interesting. So I think that is little bit problem. So this is I think not a extra load, because while we are making a interesting teaching learning process, so we must adopt a new thing. Initially it is a little bit difficult. So for that, to make a teacher first interesting this topic, or arranging some workshop as like. Okay, thank you.
Thank you. One of the problems we also have, it has to do with our mindset, our academic mindset, or you can say we don't really, we are not corporates, so we are not aggressive. So, in fact, I remember we promoted GCC in a big way. Okay, so if you want to learn spoken tutorials, you have to use GCC. So obviously you can't use Turbo C, because that is one of the things we were trying to see, how to get Turbo C out. Because people who use Turbo C, some of them, when at the time of interview, we asked them, like, what is compiling? Some of them say actually F3. Okay, so if you want to move out, we said, but then, when we met this, we found that our spoken tutorials are used. So for them to work, you need to use GCC. And some of them mandated. So in fact, I asked one of the commissioner in Tamil Nadu, who mandated the use of spoken tutorials, C and Java spoken tutorials for all polytechnic colleges, 455 colleges. So don't you feel it is bad that you are mandating the use of our method? So he said, they have anyway nothing to learn. There is nobody to teach. They are at least learning something useful. Okay? Of course, coming out, I think that we are always, little reluctant to push our method. So we know it's a great method, but we say that I don't want to seem too aggressive. While corporates do it all the time. I think we should, educators, content creators, open source communities and so on should be a lot more aggressive. And in fact, that is, most content creators create them and leave them. You take it or leave it. It's excellent stuff, take it or leave it. But I think that we should take the responsibility also to spread that. We tried this with great success in spoken tutorial. We have 30 people who are into content creation and 30 people are pure marketing people. Ours is probably the only project where 50% of the people only push what we create. And one might ask, I mean, what is it? What are they doing from IIT? But you have to, see. I think so. We got to be clear about our model. We should say that these are the things we want to do, but it is not enough if we just leave it, create it. We should actually give a push to it. And, go all the way to the end.
Thank you. So one of the heartening things about this is, from the general comments, it seems like it's a very, very surmountable problem. That teachers, even though they are fully loaded, it looks like there's enough incentive by learning such material that there's a good chance this will be adopted. So in the interest of time, I have one more question, but I'm requesting you to be brief in the sense that apart from the 3 points, they've already looked at one major issue being adoption, the second issue being availability of computers, one of which has already been addressed that apparently most schools have computational facilities, but mostly only for teachers, not yet for students, which we are saying that is good enough in the sense that the first attempt should be to at least enable the teacher. And it seems clear that the material is going to be definitely of help. So apart from this, an availability of computers, which is a much larger problem, is there anything else in very brief, if you think there is something, if you would like to share, that would be great. Otherwise, we can move on to user questions.
I think if this can also be incentivized in the sense that, as you just said, that you have this annual inspection or evaluation where you have to show what teaching aids are being used. So if at some level, I do not know what is the right level to take this up to, but teachers who are using digital aids, who are using open source software, if this can be incentivized, if they can be sort of given extra marks or extra points for this, I think it will catch on like wildfire. I mean, if we just say that if you use this material is available, here are computer systems available, and you'll get points.
So I believe we have the director of JV school. So if you would like to share a few comments.
One experience in CBSE, 2014 CBSE evaluation, CBSE introduced OSM system, on the screen marking. From the regional office, all the answer sheets, it is displayed in the evaluation center. And teachers, evaluation teachers, they got training. Many teachers, subject teachers, they were afraid to attend the training session because they are not acquainted with computers. Then from CBSE, so much pressure was there. Then that evaluation duration was extended, and a lot of pressure was there from the regional office. Regional officer went to different places. Evaluation centers were there. Only on the screen marking was there. Automatically the marks it is collected in the center. It was very good system, but due to they could not push it as per their requirement, and 2015 they dropped that OSM system. Now manually evaluation is going on. That only the 2014, that very good system they started, the CBSE they had to drop it. That is why in the discussion it was come to that point that how we can push it. Still that also did not work it in many centers. I don't know others. The Guwahati center, they used this OSM system. Other states, I don't know whether it is regional offices it is used or not.
So basically you're saying from 2014 there has been a program in place to do the incentivization.
There is this computer, how teachers are keeping away the maximum cases, particularly the older generation teachers, new generation teachers, they are eager to use computers, these new systems, that adopting the system, but older generation teachers, they used to keep away, and that is why the implementation level, it may take time. It is not that easy as per our interest. It may not be that easy to implement it.
On this training part, I like to mention something. There's one example which I have some exposure is the IT at School project, that is the Kerala government's scheme. Probably that is the largest deployment of free software in education in the world.
And it's
4,000
unfortunate we don't have someone from that committee here. But
And what they followed is, initially, I mean 2000 when they started, they selected 200 teachers as master trainers. And these 200 teachers were trained by external experts. And after that, there is no external expert. They are on their own. So probably that method, if you, not 200, suppose say you come with say 20 teachers, and probably some of us can spend our time and train that 20, then it has to go as a chain reaction. So this probably you can consider. I think
So
none
this
of
is
us will
exactly
say
what
no
the-
if you come with a group. But they should be your master trainers. They should be willing to take it forward. We can probably try that approach because that was a success that we have seen.
But this is kind of the same model that we use for the 10,000 teacher training program.
Again,
You
right.
train the trainers first, then they serve as TAs for the rest, and then you have a remote education by which all of them can learn.
Then we should offer it to them, right?
We
Right?
should offer
That's
it
what
to
I'm
them.
saying.
So that is eventually something that.
So, regarding training the teacher, it is fine. You will have the scale, multiplication effect. But we found that as far as programming is concerned, it's better to go to the students directly. Okay, that's the reason why we found in spoken tutorial that because they belong to the next generation, they catch up very fast, right? So I would go to so I'm not saying that do that only, but what I'm saying is don't talk about only teacher training. Take both of them. Whichever flies is fine. Teacher training is very good. If it catches on, then you have the multiplication effect. But there is a possibility the students pick them up, a lot faster, which is what we have done in spoken tutorial. Although I should point out that there are some topics that are extremely popular amongst teachers, not so much with the students. That is, for example, LaTeX. LaTeX is extremely popular with teachers, college teachers, for example, because many of them pursue higher studies. They want to write a report, they want to write a paper, they want to make presentations. So we have trained, if I'm not mistaken, about 70,000 people on LaTeX programming in the last about 4 years. So which I never imagined. I mean, something like LaTeX, 70,000, most of them are teachers. I never expected. So I think let's do both. Let's go also to the directly. The other thing I wanted to point out is this recognition. This recognition need not be in the form of brownie points, promotions. It may just be recognition. That, for example, we are running a pilot now, they didn't mention, where we have given on loan our laptop to every teacher in the school, going by, what Supratik said, let every teacher start using a computer. Okay? This is something important because it's a rare thing in India. Even college teachers don't have their own laptops. Right? And I don't want to wash dirty linen here, but let me just leave it there. It is not a done thing. But if KVIIT says, look, all the teachers have computers, and using that, we are able to come up with so many nice ways of, teaching the same topic. And of course, 75 computers is not a big number for a school like KV that has, let's say about 2,000 teachers. In fact, 2,000 students. In fact, any school that has 2000 students should be able to give a computer to every teacher in that school. I'm sure we can find corporates, sure we can find NGOs that will make this possible. But only thing is it worthwhile? Is it working? Are they benefiting? So first thing that we want to make them say, it benefited them. So the recognition that, in fact they said, we are the first school in the country where every teacher has a laptop. Every KV, for example, right? So there should be, people should feel good about it, but eventually at the end of the year they should say, we did something useful with it. So if we can do that, then recognition can also be equally good. Because sometimes the other things may be difficult. If you ask a director or an administrator and say, can you give a promotion? So that will be very difficult. Nobody can accept that in a public meeting, right? So, but on the other hand, there are many ways of enabling this, making people feel good about it, and eventually they will definitely move faster than other people.
Thank you very much. We are running short of time. Thank you so much. You had such fantastic ideas. If it's okay with the audience, I'm opening the panel to the audience. As in, if you have any questions, feel free to ask. Can we have another 15 minutes? Fine.
So first and foremost, I am very thank you for spoken tutorial. That was very great idea. And I am also one of the user for spoken tutorial, and henceforth I am here today because I know about it. I know about the Python, but there are some criteria in that, such as what about the schools where there are no such facilities? But the idea which I came to know that you are renting the systems. If you will rent this system for the schools where there is no computer facility, for the at least for the workshop time or the spoken tutorial time, so that would be more beneficial over there. And the awareness point of view is the great one, because very few people know outside or the place where there is no technology. The staff in the proper cities or the highly technical cities, they know about this all new technologies. But what about the all about these stuffs in the rural areas or the small cities? So there should be also be increased this technology over there. That's my.
So if I can quickly answer, I think we are not going to be able to solve all problems overnight. So I would go by what our teacher friend suggested, that in Maharashtra, almost every school has a computer lab. The question that we should ask is, are those computer labs used fully? I'm afraid that it is not so. In fact, we met one bureaucrat, Maharashtra state bureaucrat. We took Akash tablet and he said, look, I have given computers to every government school in Maharashtra. We don't know how to use them. Can you please help us? So I would say our problems are huge. There are 300 million students who need computers. If you want to give a computer to every child, every student in the country. That's almost like the population of the US, right? Every one has to be given. We are not going to solve it overnight. It will take decades. But are we using our existing facilities efficiently? I think that's what we should do. And best thing is to go to, I would say our experiment in KV IIT is a great one. I mean, in fact, hats off to Supratik for having proposed this, that we have gone with this. We should do our best to make sure that that experiment succeeds. Okay? Do everything, make it successful, Because for the KV Sangathan, if it is so successful, they will replicate this in at least 10% of the schools as a pilot. Then they can say, okay, if they do it, CBSE and lots of other private schools, it's all possible. I am a lot more positive. I believe it is doable. Let's do it slowly, but do it well.
Yes, thank you, sir. It is very good thing that the physics, mathematics, these subjects, if the students learn with the Python. I want to know, is there any such at present any school available where these things are implemented so that any new school wants to implement it and the principal or the teachers wants to see what exactly happens if the students are using the Python for the learning maths and physics. So, is there any, if it is there, any role model available, then that is very good thing that other schools will definitely look for that and they will adapt it quickly. Any such model in Mumbai or anywhere?
Yes, I am KV teacher, Kendriya Vidyalaya IIT Powai. So this is a role model school. So all the teachers are using new technology. So this is helpful to other school teachers also and other school students also. Because this Kendriya Vidyalaya is a second government school in the country. So there are so many visitors across the country and foreigners also visited in our school. So Japanese school are also visited in our school. So our school normally using all the new technology, we adapted all the new technology. So I also thankful to our IIT professors providing this Vidyut laptop. So when we got this laptop, immediately all the teachers are using. On the 17th in our school there is inspection, so that the principal told us, you have laptops, so there must be computer aided teaching. So in that day, all the 75 teachers are teaching by using computer. So this is the impact of this Vidyut laptop. And also I am speaking about this tutorials, spoken tutorials. That is very good, because when I just used, I opened in my computer, at that time few 11th students are there, they also seen. And in that tutorial, there are so many languages. So students also learn that by using that tutorial, their own language. This is also very helpful. So again, I am thankful to IIT professor providing this. Thank you. Our school is a role model school. So many visitors are visited there. So that is helpful to all across the country, all the students as well as teachers.
Part of the plan is to use this material that Dr. Ajit has been building. In fact, at FOSSEE also we are trying to cover some of the textbook. We plan to share it immediately as soon as it's ready, and we are happy with it with the teachers. Conduct a workshop showing how this can be used, and then study the effects, say, for a semester. So by next summer, we probably get a lot more data as to how it has been used, how the computer has helped us. So that itself is a valuable. Any more questions?
Actually, sir, I wanted to ask you that question that you spoke about GCC library. So, actually, I am from the Department of Information Technology. Like, I am doing my part 2 in Masters in Information Technology. So, I wanted to ask you that, well, if we are not using the GCC library, because it comes under the SIGWIN, so probably if we are using the Linux console, that is like CentOS is there, Debian is there, Ubuntu is there. So basically if we use that, there is no necessity to use the GCC then, because GCC is little tough to as compared to this open source consoles, like open source systems.
C compiler.
No, it is a open source, but
No. GCC is a C compiler.
Yes, it's a C compiler, but it uses the Linux properties. Like we have to generate from Linux. So that will be like, it will be very difficult to learn, first of all, because if we are doing by Linux, like if we are writing
No,
the
you
code,
just need some header files
Yes.
even in Windows, you just need some header files for our, see, we have spoken tutorials that are based on GCC. In order to use them in Windows, you need some extra header files. If you do that, then your normal C compiler will work, open source C compiler will work on Windows. You don't need Turbo C.
Okay.
Turbo C means you have to buy it.
Yes.
And how many people buy software? How many software have you bought? Thank you.
Yeah, one more question.
So just simple question one. Actually, like I'm from CBSE medium. I passed my 12th from CBSE. So generally CBSE has introduced a subject in computer science. So those who are taking science, so they can take computer science, so they can learn C and C++. So similarly, if those who are taking commerce, so they have introduced subject on Java. So can you suggest some people in CBSE, or so we can introduce a subject on Python, or because generally that will be more easy, I guess, because people, they are very much aware about C and C++. Because we have in boards also in 12th CBSE, we write a paper in 100 marks in C++. So can we introduce in class 8, 9 or 10 very simple Python programming as a part, or even class 11th or 12th apart from that? Like if you can suggest the state board people or even CBSE people. So maybe I think that may that may increase more awareness actually, what I think so. Yeah, so it can
Which
be
one? Python.
Yeah.
Python.
So we would like Python to be introduced at an earlier class, say 8th
So-
or 9th. Is
So
that
let me just give some feedback on this. CBSE wanted to make Python compulsory and at one time in the school system.
for 11th and 12th.
Yeah. Yeah. And unfortunately, there was a large section of teaching community that got worried, because Python was an unknown animal. Right? Not much was known, whereas C is something that is known. You have been using C for, to teach year after year. Suddenly you want to learn something and you want to make it compulsory. So after a lot of protest, it was made optional. Right?
So you'll notice that in our presentation, we deliberately did not mention computer science for exactly these reasons. We are aware that it was made compulsory, and that they pulled back because of the resistance from computer science.
And in fact, now there is a reason to believe, some people told me in one of the meetings in Delhi, that they are actually thinking about getting rid of Python completely. Okay?
So our
So-
approach has been to do the
So I think that is
Side
why it is important to do this PR. You have to do marketing. It is not enough if you know that Python is a great language. ZTV should talk about it, or some minister should talk about it. Which will happen if they do well, and there is an interview, and some student comes and talks in Hindi. Hey, I'm learning Python. It's a great thing. Okay, I think that we need to think about strategies. I think strategies are going to be important.
So do you also think that, building on his question, is that right? So the question is, supposing we introduce it in the math and physics curriculum, do you think the schools will be more encouraged to now do it, or will the CS teachers continue to resist its adoption? So basically, as you know, computer science, it was supposed to be
Actually,
optional.
if that is in the syllabus for the CS, so some difficulties in mathematics and physics, students can do in at home also. So that is also helpful to students. And I request one more thing. This is also this Python. This language also helpful to the students. So normally I am doing in material science, in nanomaterials. So we need some plots. So there are so many softwares to draw the plots. So this is also very helpful, and this is also need of workshop in universities also for a research student, for a PhD student. So I also use this. I learned this Python, so I also use this for plotting.
But the thing is, do you believe that computer science teachers in your college will also be equally excited about Python as you are?
Yes, yes,
They will.
yes, yes.
Any more questions? I think this will be the last question since it's going to be.
I just wanted to know if there is any plan going on to introduce this kind of program or course even at undergraduate college levels. If you talk about undergraduate physics students, okay, Ajit sir had shown a few demo programs which were related to school physics. If I talk about a simple, like a spherically symmetric potential, we start writing with Schrodinger's equation, we do a lot of mathematics, and then at the end of the day, a student would not know how does it actually look like. So would there be, it would be like really benefited the students and the teaching fraternity alike if you could introduce these kind of programs even for undergraduate college students. So is there any plan going on?
See, schools we are talking about because it's a centralized thing. CBSE or somebody can take a decision if you finally convince them. But colleges is a totally different thing. Every university has the freedom to, include or not include. And for example, like I was talking about the experimental kit, the Phoenix kit. Pune University and the Calcutta State University, Calicut State University, they put it in the syllabus. It was their decision. Similarly, if you collect all these things and if you convince your colleagues, because it is totally up to the academic committee, right, which decides the syllabus. These are teachers only. So the cases are different. Schools, teachers are not really deciding. There is some other officials involved. But colleges, it's decided by teachers only. Some committee, that is, teachers are the only members. So you have to get convinced yourself, then spread it to your colleagues, and many of them will be the committee, they will decide. So that's an external, only thing we can do is just provide the material and try to convince you people.
So, I'm a little more optimistic about this. I told you earlier that spoken tutorial is now used in 1,000 academic. That means, just to give an example, a college could say, I have BSc IT second year students who do Java lab every Tuesday afternoon 2 to 5. During the time, they shall learn from Java spoken tutorials. So if they say that, it is one program in my accounting. I have 1,800 such programs that have accepted different spoken tutorials as a part of their curriculum, and they have given them in the timetable. In order to do that, it has gone through all the things that Dr. Ajit Kumar mentioned, convincing the curriculum committee, syllabus committee, vice chancellor, principal, all kinds of people. So it is definitely possible. What is important is to come up with a set of programs that that he has done for school at the college level also. We have to do that mapping. Let's say we have this, let's say BSc physics, let's say light or optics or whatever it is, and you say these are the things that they will do. Here are, let's say, Python programs. Okay? We need to create that kind of material. In fact, that is the kind of thing that Professor Prabhu wants out of this gathering, that we will find volunteers to do that, precisely that kind of stuff. So if we can create that, even if we don't do this for whole book, supposing you say that we want to do this for diffraction. Okay? So here are all the experiments using Python. I've come up with this. Let this not be for the whole book, but for, topic wise. If we can do that, then the next level is go on convincing them. I'm sure we have enough enlightened people. maybe small number, but we can start from there.
So I think that would be the last question.
Yes, working in the university, I am working in the one university and the board of studies also. So I could introduce the Python in the SNDT Women's University in the engineering college. But in the Mumbai University, in the VJTI people, they have introduced it, being autonomous. In the Somaya College, they have introduced it. But in the university structure, it takes a lot of time. Now it is duty, or the students should propagate all these advantages and all these things through the social media and your contacts, so that if students start using it in the projects, many projects, seminars and everywhere, then definitely university has to do it at early as possible. Definitely it will do it. Students' motivation is much more important. Thank you.
Thank you, Professor Kannan. Wanted to.
Yeah, especially because Dr. Ajit Kumar called it a tablet. So I want to, it's not a tablet, it's a laptop. Yeah. So that's, anybody.
So I think formally our program closes here. I'd like to thank all the panelists and all of you for staying back for an extra half an hour. Tirumalesh is just going to show one little book that he has done. I don't want to hold up the audience on account of that. He's just going to show one little demo of a IPython notebook that he made. You know, the idea is we want to make more such examples of a live demo with sliding interactive widget. So you can see interactively some particular example that he wants to show. So, in the meantime, I'd just like to propose a vote of thanks to all of the panel members. Thank you so much for being with us and spending your valuable time, and for all of your thoughts. And to the audience, I sincerely request you to please contact us if you are interested. Please contact any one of our volunteers, and I would like to nominate one of them. Is Srikanth here? Srikanth. So I will ask them to give you the email addresses if they are interested in adopting a school. Just please, you can meet him. Give him your email address if you are interested in taking up a school and trying to push this content. Thank you very much. Thank you all. So see you tomorrow. Okay. So
This is a demo of right hand thumb rule showing the effect of electric current over magnetic field. So you can see that according to right hand thumb rule, if the current is coming outwards, so the field lines will be in the curled directions, and if you change the direction, you can see a cross mark here. It means that the current is into the plane of the board, so the magnetic field also changes the direction. So this is one of the examples to visualize the electric and magnetic field data. And there's one more example, and this is an example for the electric field lines produced due to point charges. So as we all know that the point charges produce electric field. So when there are no charges, there is no electric field lines. So let's say we increase the magnitude of positive charge. The field lines emanate from the positive charge. Similarly, if we consider a negative charge, the electric field lines must terminate on the negative charge. So if there are like more than one charges in a plane, a negative and a positive charge, so the interaction between the field lines will be in such a pattern. And if there are
like charges, say both are negative, they have to repel from each other.
There is just one demo. This is hosted live actually, currently on try.fossee.in. So the idea is we'll host a lot of these and make it easier for students. So, 20 lines. Can you make it in 20 lines? 20 lines of code, can you write it? I think it should be doable. Correct. So we need more work on it. It's just a demo of what you can do. Thank you very much. See you tomorrow at 8:30 for breakfast.